All right, we are back at AP Review. This is 2018 BC Free Response 2. All right, so researchers on our boat are investigating plankton cells in the sea. At a depth of H meters, the density of plankton cells in millions of cells per cubic meter is modeled by P of H, which I've written here, from H values of 0 to 30, right? And then for depths beyond 30, they're modeled by f of h, which we're not given. We're just told it's f of h, and it says the continuous function f is not explicitly given. Part A, find p prime of 25. Using correct units, interpret the meaning of p prime of 25 in the context of the problem. So the first thing I did was I typed this function into my calculator as y1, because it's a calculator section. I know I'm going to have to do it. So my y was the p, and my x is going to stand in for h, right? So I put that in my calculator as y1, right? So part A is asking you to find p prime of 25. You're just going to make your calculator do the heavy lifting. There are two ways to do that. You can either do n derive, which is math 8, and do y1 with respect to x at 25, which is fine, right? So if you quit out, it's going to look like that, and you hit enter. Or there's another way to do it, but I'm going to suggest that that's the easier option here. So you're going to get a negative 1.179. So this is the rate of change of P, which was measured in cubic meters, millions of cubic meters. So this is millions of meters cubed, right? Per meter of depth, right? So like per meter of depth in the water, right? What this means is this is the rate of change of the density of the planktons in millions of meters cubed per meter of depth, right? Depth, sorry, not depth. So it got real dark really fast. So if you want to say meters cubed per meter, you can. You shouldn't say meters squared because they're different meters here. A meter is a meter, but one of them represents meters of depth. So at a depth of 25 meters, the density of the plankton, is it plankton? It is. The density of the plankton is changing at a rate of negative 1.179 million meters cubed per meter, right? Don't cancel the meters because you're talking per meter of depth. Okay. Part B. Consider the vertical column of water in this sea that has a horizontal cross section with a constant area of 3 square meters. To the nearest million, how many plankton are in this column of water between h is 0 and h is 30? So whatever the density is, right? So the number of plankton, right? So let me erase my part A, right? So the number of plankton, let's just pretend it doesn't matter what shape this column is. It doesn't matter if it's a circle or a square, right? So in this column, we have some area, right, that has an area of 3 square meters, right? And there's some density that is represented by P. So the number of plankton is going to be the density, right, P of H, times the area, because it's the density the density of each spot multiplied by the area, right? If you want that for the whole column, what's going to happen is you're going to integrate. You're going to start from depth of 0 and you're going to integrate all the way down to a depth of 30, right? And again, it doesn't have to be a cylindrical column. It's just a shape that has an area of 3 square meters. So if I want the total number of plankton, what I want to do is I want to do the integral. So my answer to B is going to be the integral from 0 to 30 of a 3 times P of H with respect to H, right? That's what I want. And again, I'm going to write that, but really all the AP cares about is me writing that and then giving them an answer. Typing it is on me. So I'm going to type in function integrate, which is math 9. And you could put the 3 in front, or you could either treat it like this, or you could put the 3 out of your integral like this, because it's a coefficient. So it really doesn't matter. So I'm actually going to put the 3 in the front. I'm going to do function integrate y1 with respect to x from 0 to 3, and it's going to give me an answer, right? So again, I'm going to type in my calculator 3, math 9, which is function integrate. I go to vars, I go to vars, y-vars, function y1, comma, with respect to x, from 0 to, it's not a 3, it's a 30, come on brain, 30, to 30, and I hit enter. Right, and I get that it is 1675.414 or 5. And what they ask me to do with it is they ask me to the nearest million, right? So this is million, right? Like this is this many millions of whatever. So the answer is going to be 1675 million plankton, right? To the nearest million, because this wouldn't round, right? So that's my answer. Cool. And it does say to the nearest million, so be careful about that. Cool. Part C. Part C. There is a function u such that 0 is less than or equal to f of h, which is that other function for h values higher than 30, is less than or equal to u of h. We don't know what u is. For all h values greater than or equal to 30. So they tell us that the integral, so this is part C, they give us that the integral from 30 to infinity of u of h, which is a function we don't know, with respect to h, is 105, right? And remember, what they told us was that 0 is less than or equal to f of h is less than or equal to u of h for h values greater than or equal to 30, right? Okay. So the column of water in part B is k meters deep, where k is greater than 30. Write an expression involving one or more integrals that gives the number of plankton cells in millions for the entire column. Explain why the number of plankton cells in the column is less than or equal to 2,000 million. Cool. So here's what we know. So the number of plankton in the column should be the same formula we just used in the last part, except the difference here is that instead of going from 0 to 30, we're going from 0 to k. So we have to integrate from 0 to 30 of p of h dh times that 3. Sorry, why do I keep making that 30 a 3? I don't know. Plus the 3 times the integral from 30 to k, whatever k is, because it's after 30, of f of h dh, right? Well, we already know the answer to this thing. The answer to this thing is whatever I wrote down from the last one, which was like 1675.414 maybe? 414 or 5, right? 4 or 5. Okay? And we know, right? So that's what this is. So this is the integral expression for what they want, right? This is the expression that they asked for. Okay? So that's the first part. Second part is they wanted me to show why this has to be less than 2,000 million. Well, this quantity right here, since f is smaller than u of h, this value must be less than, essentially less than, so this is at most, right, because it says less than or equal to. The biggest that this thing could be would be a 3 times a 105, right? Because if f were actually equal to u, because that's an option, then this thing would be a 3 times a 105, right? Like at best, at the most, and that's if this went to infinity. So if this is going to infinity, it comes out to 105. So this is definitely smaller than this, and so I get 1675.414 or 5, doesn't matter, plus a 315, right? And if I type these numbers together, I get something in the 1990 range, right? 0.414 or 5, which is less than or equal to the 2000, right? So even if this thing were as large as it could possibly be, the biggest value I'd get is 1990 something, right? Which is definitely smaller than 2,000 million, okay? So that's what they meant by showing that. All right, part D. So I think part D, they switched to a completely different problem. So far, the only part of this question that has been BC calculus was that they used, at one brief point, they gave you an integral that went to infinity. They didn't even ask you to do much with it other than the fact that it had an infinity. So part D is parametric, which is how we get a little bit more BC topic in this BC question. The boat is moving on the surface of the sea at time t greater than or equal to 0. The position of the boat, x of t comma y of t, is given by x of t comma y t, and they give us x prime of t equals 662 sine of 5t, and they give us y prime of t equals 880 cosine of 6t, right? And then they ask us to find the total distance traveled by the boat from 0 to 1, right? So really, this is just a matter of, so you're going to switch modes, right? So you're going to have to switch, you're going to have to take your calculator, and you're currently probably in function mode, because that would make sense. So you're going to switch to parametric, right? And you're going to go to your parametric stuff and clear whatever else is in there. You're going to type in 662 sine of 5t. You're going to type in 880 cosine of 6t, right? So that should be what we have there. I'm going to double check before I proceed. Yep, okay. And then it's about remembering the total distance formula. So total distance in parametric is the same as arc length. So the total distance formula is going to be the integral from 0 to 1 of the square root of x prime of t quantity squared plus y prime of t quantity squared. What's funny is they did you the solid of already giving you x prime and y prime. So this is what you have to write for the AP, right? This, and then you're going to type and write an answer. That's it. But what you need to understand how to do in your calculator is you need to do function integrate, which is math 9, right? Square root of x1t quantity squared, because that's your x prime, you just put that in, plus y1t quantity squared, close the parentheses, with respect to t from 0 to 1, right? So again, the calculator's never going to, or the AP's never going to give you credit for calculator syntax, but if you can't do it, it's a problem. So I press math 9, right? I do the square root of, and then I go to vars, I go over to yvars and pick parametric. I want x1t quantity squared plus vars over to yvars, pick parametric y1t quantity squared, close the parentheses, comma, with respect to t from 0 to 1, and I hit enter, and it should give me the value I want. We always can hope. It's still thinking. Obviously make sure in radian mode, but that should hopefully be the standard. There are reasons on the BC test to switch between function, polar, and parametric mode. There should never, ever, ever on a calc test be a reason to switch out of radian mode. Calc always is in radians. Yep, and I get 757.44 or 455 or 456. So 757.455 or 6, depending on if you round or truncate. And because this is a problem with units, I need to make sure I have units. It was moving in meters. So meters, right? Total distance in meters. Cool. Again, remember in parametric, arc length and total distance are the same because the arc length of the curve would be the same thing as like how far you'd drive if you were driving on the curve or boating on the curve or whatever other mode of transport you were using on the curve.